As we go on now to Chapter 3, Systems of Linear Equations and Problem Solving. Well, Topic 1 is systems of equations in two variables. Now, what are they talking about here? So let's give you a little review of what we did in class. And we said if you had an equation in standard form, and you had a second equation, well, let's get the right letter there. Okay, and there's your second equation. Now, as you look at the first, this is in standard form, and you look at the second, this is in standard form. And if you made the graph of the first equation, and it was this line here, and you made a graph of the second equation, and it was this line here, you'll notice something interesting, that right over here, they're intersecting, and the ordered pair of that particular point might be like 1, 2, 3, 3 up, and 1 over would be like over 1 up 3. This ordered pair would be a solution for this line, and this ordered pair would be the solution for this line, because they intersect at that particular point. So what this is to give you a little background on what's going on here as we think of systems of equations. That here, this is one, this is another. They're both in standard form, and they are different because the x sub 1's and the y sub 1's and c sub 1's are different from the x sub 2's, y sub 2's, and c sub 2's. And when you graph them, they intersect at that particular point. So this is a unique solution. It's only one point where these two graphs intersect. So we say that's a solution for this system of equations. Now, suppose we did a graph of example 1 here, and it was this line, and example 2, and we plotted it, and it was this line. What do you notice about these? Well, these lines are parallel. Will they ever intersect? And the answer is no. There will be no intersection. So the intersection is an empty set, or there's no solution, because these lines are parallel. Now, let's look at another scenario. Suppose we took equation 1 and we plotted it on this graph, and then we plotted equation 2, and lo and behold, one line was actually on top of the other. In a sense, they were the same equation, but it may look a little differently as you look at them. But in essence, they are the same equation. They have the same slope, the same y-intercept, and one line is on top of the other. So what would the solution set be for this? Well, can you see that if you had an ordered pair for one line, that would also be an ordered pair for another line? And how many points did we say are along this line? Remember, there's an arrow there. And the answer is there's an infinite number of pairs along this line. And one equation, the same as the other, we say there's an infinite number of solutions. And the way we write it, usually in set builder notation, we'll say that x comma y is such that, and then we give one of the equations, because the other is just a modification of the same equation. Okay, So that's a little background of what is going on in section 3.1. So we've done the lesson. Now let's take a look at the vocabulary. I'll pause it and then we'll see what you get. Now we had covered these words through examples, but now the vocabulary. So a system of equations is a set of two or more equations in which two or more variables for which a common solution is sought. So we had three cases: one solution, no solutions, infinite number of solutions. When solving systems of equations graphically, we look for the intersection. So that's good. We're going to do it mathematically primarily, and I wanted you to see and tie it in to the graphic solution. You're looking for that point where the x and y coordinates of one system is the same as the other. So a system of equations that has at least one solution, we say is consistent. So that would be the one solution and the infinite number. And then if the lines were parallel, there's no solution. This is inconsistent. And if one equation in a system of two equations is a multiple of the other, that was when they're the same lines, we say they are dependent. If either equation in the system of two equations is the multiple of the other, the equations are said to be independent. So, applying these words to different situations, that's your challenge. All right, let's go on. Now in this one, they're asking us to determine, is this ordered pair a solution? So what you need to do is take this x and this y and place it into these equations and see if in fact the statements are true. If they're both true, then yes, that is a point of intersection. And the same for number 8. I guess I let it run, and you saw that I had a little error when I did this one, but this one should be a positive 3 and a negative 5 is a negative 2, and this has a positive 2 there. So this one is not true, and this one is true. Okay, here we're asked to solve each system graphically, and you're wondering what technique might you use. Well, here you could use the x and y intercept t-chart. Here you might solve for y, and a similar way for the next one, but I'll do one at a time. Yeah, that's better, because as I was going to review it with you, the slope is, I had my y-intercept correct, but it's over 2 up 1. So our point of intersection here will be 4, 3. So never hurts to check your work. I know that from experience. All right, to keep this short, again, I've made a t-chart. Here are my points for the first equation. Here are the Again, our y-intercept for the second equation happens to be the origin. I carefully put in some points and carefully marked it out. So our point of intersection for number 10 actually is right here, -1, -3. How did we get it? By graphing. Okay, as we look at example 11, and again, what I did here is I used the technique of solving for y, a positive y, and I did the same here. Now when I did that, notice what happens. Our slope is exactly the same. Our y-intercepts are different. There's the y-intercept, there's the y-intercept. So when we graph them, they are parallel lines. So will there ever be a solution for this? And the answer is no solution. An empty set. Okay, as we look at example 12, again, what you want is a strategy. So there is your x and y intercept t-chart, giving you the red points. And there it's in slope-intercept, where we plot the y-intercept at 4. And then this is 2 over 1. So from 4 we go over 1 up 2. Then if you carefully make your lines, and that'll be the thing, you have to carefully make your lines. In MATLAB, that's rather easy to do, but you need to know what your points are. And then our lines of intersection, or our point of intersection, is at -2, 0. Now in example 13, as you see it there, they don't look like the same equations, do they? But I left this one in slope-intercept form, and then I saw something, so I solved this one for y. And lo and behold, when I did that, I ended up with two equations that were exactly the same. So let's plot this one. +1, then over 1 up 2. This will be one line. And when I plot the other line, it's right on top. So this is a case where there's an infinite number of solutions, and the way to write the answer, you can choose either of these, but you use set builder notation. X, y is such that, and you just write one of the equations. Now you could have written the other one too. Either one is good. And on a paper test, they'll probably give you a choice, as they will in MATLAB. They'll say one solution and you put the ordered pair in, or they'll say there's no solution, or they'll give you this as a solution. And you just choose it. Okay, in these next, and they get to be a little tedious, we're working on some word problems. And the nice thing is, with two variables, it often is a little easier to set them up anyway. So here they're saying the sum of two numbers. Well, x is the first, y is the second. So the sum of these two numbers is 24. The first number, which is x, is equal 50%. Now you can put it as 1/2 or the decimal 0.5y. So there are your two equations. Now they're not asking us to solve them yet. Here we're just practicing putting them from English into algebra. For number 16, they're saying angles are complementary. Well, this means that their sum is 90 degrees. If they were supplementary, that would be 180. Now they're saying the first angle plus twice the second angle is 126. So there are equations as systems of equations that we're converting from English into algebra. Now in our next section, we're going to solve these. Here the Eagles score 30 goals. And there are two types of goals. There's a 2-pointer and a 3-pointer. So the 2-pointers plus the 3-pointers, the number of them, equals 30. Now the actual score counted as this many points. Well, what does a 2-pointer count as? Well, 2 points. And a 3-pointer counts as 3. And the total is 63. So we have set up systems of linear equations in two variables that match what's over on the left there. Okay, for number 18, what you would need first is to keep in mind the perimeter formula. And their perimeter, we know, is 128. And there's 2 lengths plus 2 widths. There's our built-in 2 unknowns. And they're saying that the width is 24 feet less than the length. There's the length, less 24 feet. There's your 2 equations. And again, we don't have to solve them at this time. Now, number 19 would take 20 minutes to do all by itself. So let's just talk about what strategy if you had to do this. And I wouldn't give you one that's just difficult on a test or even for your homework. So here's sets of data. So we have a year, we have enrollment, year, enrollment, and that applies for these 2 schools. So you could take any 2 of these years, probably this one and this one, and figure out what the slope of each line would be. First this one, and then do the other one. Once you figured out the slope, you would then use one of these points in Formula 4 to figure out your equation. Well, here they're giving you the equation. And you could see that this would be tedious to figure out. But it's something you can do. And again, we're not asked to solve it. We're looking, again, for perhaps some point where the enrollment in the 2 schools would be, well, it's actually over on this side here. So I can't do a straight line there too well. Right over in there, it would be the same for both schools. Okay, that wraps this up. Again, you're going to use your graphing skills from Chapter 2. We'll have a test only on material that we've actually covered on this Chapter 3 once we get all of the stuff in there. We still have 2 more sections on Chapter 3.